Touch something. Go ahead. Your phone, the table, your own hand. It feels obvious what touching means. Your finger reaches the surface, makes contact, stops. End of story. Except physics quietly says something that should bother you. You never actually touch anything. Not your phone, not the table, not even yourself. And when you zoom in, really zoom in, something deeply weird happens. Because the closer you try to get to an atom, the less solid reality becomes. Until touch stops meaning anything at all. The assumption we never question. From childhood, we learn a simple picture. Matter is made of tiny solid balls. Objects are collections of those balls. Touching happens when the balls press against each other. That picture feels right because it works at human scale. But it collapses the moment you ask a dangerous question. What actually stops your finger from going through the table? Not metaphorically. Physically. What force intervenes? What mechanism says, no further? Most people instinctively answer. The atoms hit each other. But that answer hides a problem. Because atoms are mostly empty. The atom is not a tiny solid thing. Let's shrink. Past skin. Past cells. Past molecules. Until you reach an atom. What do you find? Not a little marble. Not a solid bead. You find a tiny nucleus, unimaginably small, surrounded by electrons, not orbiting like planets, but spread out as probability clouds. Between the nucleus and those electrons, nothing. No stuff. No substance. No solidity. Just space. If an atom were the size of a football stadium, the nucleus would be a grain of sand at the center, and the electrons would be a faint mist near the outer seats. So here's the uncomfortable realization. When you touch a table, your atoms are approaching something that is almost entirely empty space. So why don't you pass right through? The force that isn't really a force. The answer most textbooks give sounds reassuring. Electromagnetic repulsion. Your atoms repel the atoms in the table. Case closed. Except that explanation is hiding something again. Because repulsion suggests pushing, like two solid things pressing against each other. But at the atomic level, nothing is actually pushing. No átomos que laivem. No surfaces meet. No particles bump like billiard balls. Instead, something much stranger happens. What really happens as you get close? As your finger approaches the table, the outer electrons in your atoms approach the outer electrons in the table's atoms. And electrons don't like sharing the same quantum state. Not because they're stubborn, not because they're solid, but because of a fundamental rule of reality. The Pauli exclusion principle. It says, no two identical fermions can occupy the same quantum state in the same system. Electrons are fermions, which means as your finger gets closer, the combined system of electrons is forced into a higher energy configuration. And nature hates higher energy states. So something has to give. Nothing touches. Energy just rises. Here's the key idea that rewires everything. Your finger doesn't stop because it hit something. It stops because further closeness is energetically forbidden. As electrons begin to overlap in probability space, the energy of the system skyrockets. Not gradually, explosively. The system resists not by pushing, but by becoming unstable. Your muscles feel that instability as pressure. Your brain interprets that pressure as touch. But nothing has made contact. No surfaces met. What you felt was a sudden increase in energy cost for getting closer. Touch is a sensation, not an interaction. This is where intuition breaks. We think touch is a direct interaction between objects. But physics says touch is an internal sensation, caused by electromagnetic and quantum rules, preventing further overlap. Your nerves don't detect contact. They detect resistance to motion. And that resistance isn't mechanical. It's quantum. Why this feels so wrong? Your entire life experience says, Solid things exist. They press against each other. They make contact. But at the fundamental level, there are no solid surfaces. There are no edges. There is no point where matter ends. Only regions where further configurations become unstable. The universe doesn't say, "You can't go here." It says, "You can go here," but the energy cost becomes unbearable. So you stop. You're mostly not here. Now comes the part that quietly destabilizes everything. If atoms are mostly empty space, and your body is made of atoms, then you're mostly empty space too. Not metaphorically, literally. The reason you feel solid is not because you're dense with matter. It's because quantum rules are incredibly strict. They don't allow overlap. They don't allow sharing. They don't allow compression past a point. So the illusion of solidity emerges, not from stuff, but from rules. Why you never feel the emptiness. You might ask, if everything is empty, why don't we feel hollow? Because your senses evolved to detect differences, not fundamentals. Your nerves respond to changes in force, energy, and motion, not to absolute structure. As long as the rules are consistent, your brain builds a stable model of reality. Solid objects, firm surfaces, clear boundaries. But those boundaries are not physical walls. They're energy cliffs, the stranger truth beneath touch. Here's the sentence that should linger. Touching is what happens when the universe refuses to let two systems become the same system. That's it. No collision, no contact, no meeting point, just identity protection. Quantum rules keeping things distinct. A question that changes the scale of reality. So if you never touch anything, if solidity is an illusion created by energy constraints, if the feeling of contact is really the feeling of forbidden overlap, then here's the question that should make you pause. What else do we think is real? That's actually just a rule we feel because touch feels fundamental, and it isn't. In the next part, we'll go deeper into what happens if you try to force atoms closer anyway, why pressure exists, why matter resists compression, and why this same quantum rule is the reason white dwarf stars don't collapse. That's where touch stops being personal and starts becoming cosmic. By now, touch should feel like a suspicious word, not wrong in daily life, not useless, but misleading. We started with something that felt unquestionable. You touch things, they touch you back. That's how solidity works. And step by step, that certainty dissolved. No salidatems, no contact between surfaces, no moment where two things truly meet. Instead, we found rules, limits, energy cliffs masquerading as edges. So now we're left with the final question, the one that matters more than all the others. If nothing ever really touches, why doesn't everything fall apart? Why does the world feel stable? Why don't your hands drift through tables? Why does reality still hold its shape? The answer brings everything together. What actually holds the world up? Let's say it cleanly, without metaphors first. Matter resists compression, not because it is solid, but because certain quantum states are forbidden. That's it. The Pauli exclusion principle doesn't just stop electrons from sharing states. It creates structure. It creates pressure. It creates stability. It creates the illusion of surfaces. When you press your hand against a table, you are not encountering matter. You are encountering a boundary in possibility space. There are configurations the universe allows, and configurations it does not. Touch happens exactly at that boundary. Pressure is the universe saying enough. Here's something most people never connect. The pressure you feel when you push on something is not resistance from matter. It is resistance from rules. As atoms are forced closer, electrons are squeezed into fewer allowed states. Energy rises sharply, not because anything is breaking, but because the system is being asked to do something illegal. Your muscles feel that rising energy is force. Your brain labels it solid, but nothing has collided. Nothing has pressed back. The system has simply run out of permitted arrangements. Why you can't push through, but stars almost can. On Earth, this quantum resistance feels absolute. Tables don't bend easily. Walls don't compress. Your body stays intact. But now zoom out, way out, to white dwarf stars. In those stars, gravity is so intense that atoms are crushed far beyond anything we experience. Nuclei are packed together. Electrons are forced into extreme configurations. What stops the star from collapsing completely? Not nuclear forces, not electromagnetic repulsion, electron degeneracy pressure, the Pauli exclusion principle scaled up to cosmic proportions. Even gravity can't force electrons into forbidden states. So the star holds, not because of matter, but because of rules. The same rule that makes your fingers stop at a table is the rule that keeps a dead star from imploding. That's not poetic exaggeration. It's literally the same physics. Solidity is a collective agreement. Here's the quiet realization that ties everything together. Solidity is not a property of objects. It's a relationship between systems. A rock is solid to your hand because your atoms and its atoms share the same quantum constraints. Change the rules and solidity disappears. At extreme temperatures, matter melts. At extreme pressures, matter transforms. At extreme energies, particles pass through each other like ghosts. Nothing about solid is permanent. It's conditional, and that should change how you think about reality. Why the illusion is so convincing. If touch isn't real, why does it feel so real? Because evolution doesn't care about truth. It cares about survival. Your nervous system evolved to detect resistance, damage, pressure, change, not quantum states. So your brain builds a model that works. This is solid. That is hard. Don't push further. The model is effective, but it's not fundamental. Touch feels immediate because the energy rise happens extremely fast. You never get close enough to notice the emptiness. The cliff is steep, so the illusion never cracks. You are not made of stuff. At this point, the old sentence stops working. You are made of matter. A more accurate version would be, you are made of allowed arrangements. Your body is a stable pattern of quantum states, maintained by energy rules. Inside structured space, there is no solid core beneath that. No ultimate stuff. Just consistency. Just persistence. Just rules that don't break. Why this doesn't make reality meaningless? Some people feel unsettled here. If nothing touches, if solidity is an illusion, if matter isn't really matter, doesn't that make the world feel fake? Less real? Actually, it does the opposite. Because something doesn't have to be tangible to be reliable. The rules that stop your hand are the same rules that shaped galaxies. They don't depend on belief. They don't depend on observers. They don't depend on interpretation. They're stable. And stability is more impressive than substance. The deepest shift in perspective. Here's the final shift to sit with. The universe is not built from things. It's built from constraints. Not particles acting on particles, but possibilities limiting possibilities. Objects don't persist because they're solid. They persist because certain changes are not allowed. Touch is not contact. It's the moment where freedom ends. Why we'll still say touch tomorrow. After all this, tomorrow you'll still say, I touched the table. The floor felt cold. That surface was rough. And that's fine. Language is made for humans, not atoms. But now, behind the word, you'll know what really happened. No contact, no meeting, no collision, just a system encountering a boundary it cannot cross. The final image. So here's the image to carry with you. Not particles hitting, not surfaces meeting. Imagine two regions of possibility approaching each other. As they get closer, the number of allowed states collapses. Energy rises. Motion halts, not because of impact, but because the universe quietly says, this configuration cannot exist. That's touch. And once you see it that way, the world doesn't become emptier. It becomes more precise, more consistent, more astonishing. Because the most ordinary experience you have, pressing your hand against the world, is actually the universe enforcing its deepest rules. Perfectly, every single time.